we were doing at Netflix happened to be this conference in 2019. And then after that, we open sourced a bunch of our works. In this talk, I'll go over some of the work that the team did over the last sort of like 5 odd years, stuff that we open source, what was sort of like our philosophy around it. And then hyperlink, I can also do a quick as well. So for those of you who are either practicing data scientists or responsible for building or provisioning infrastructure for data science, this is the narrative that I'm going to lead with based on PyData. And sort of like most enterprises that are thinking about or sort of like heavily involved in introducing some kind of intelligence to their applications, usually they'll start with some business problem. They'll have an enterprise data scientist. The data scientist would be tasked with optimizing some business metric at the end of the day. The very first step in that sort of like journey of introducing machine learning to a business problem would involve some kind of an ID. Maybe it's sort of like a Jupyter notebook on your laptop, or like as is getting more and more common these days, maybe it's a Jupyter notebook on a cloud instance, like on your Azure workspace or maybe a account and whatnot. Which is sort of like a great way for a data scientist to get started. Sort of like also sort of like keeps many of the data governance concerns at bay as well, because then your data is not looking into something individual laptops and whatnot. That's a great start. Now the first thing that have sort of like machine learning platform builders that you have to sort of like immediately worry about is that okay, how do we sort of like connect a whole bunch of different data sources to these sort of like different IDs that user is sort of like using, and it concerns not only how you're moving data from your data warehouses and data lakes, sort of like concerns how you discover this data in the first place and whatnot. So what we sort of like came to observe during our time at Netflix was that any kind of machine learning platform, the foundation is usually often rooted in some kind of sort of data system, some data platform. And of course at Netflix we sort of like had the kind luck of using a very well thought out, a very complex, well behaved data platform. And the good thing these days is that sort of like any vendors like the Snowflakes and the Databricks of the world get sort of like similar capabilities almost immediately. Spin those up over time. And then now the next thing that our data scientists have to then think about is that okay, right now they have some access to this data, they're able to pull that data into their Jupyter notebook. Now they need to run some compute. Maybe that compute sort of like involves analyzing that data, maybe that compute involves training on. But there's usually some form of those that's involved. Many times the cloud instance that's powering the Jupyter notebook, that's all good and enough for that compute. But many times you want to sort of like spill over to a larger instance. Maybe you want to train a model that requires GPUs, and you have GPUs attached to your Jupyter instance. And how do you sort of like lift and shift your compute and move it to let's say your Kubernetes cluster or whatever way you are managing your compute resources? Maybe you want to train multiple different models in parallel, or maybe you're doing some data processing step that requires a terabyte of RAM. These days you can very easily get all of these super exotic instances that were sort of like a pipe dream only 10 years ago in your sort of like public cloud where you were sort of like for your compute. But then a big bottleneck still sort of like exists for a data scientist. How do I sort of lift and shift this compute? How do I think about Docker? How do I think about Kubernetes? How do I think about packaging my code, moving my dependencies, ensuring that the data that I was able to access on my laptop or on my Jupyter notebook, that's also accessible within my Kubernetes cluster, and if failures happen, then I can sort of like actually deal with those failures, understand your progress from here. We usually see this as being the very first bottleneck in terms of making sort of like progress in any involved machine learning project. Then once let's say our data scientists have been able to write some code that is able to get data from a data warehouse, process that data, maybe generate some features, train a handful of models out of that, maybe store that data or deploy that model from there. Then they need this process to run, let's say, every single night or every single time they have, let's say, a new data set that crosses the data platform. And usually that's the time when data scientists start looking towards workflow orchestration. A laundry list of those is Argo workflows, Prefect, Daxter, airflow, a whole bunch of those that already exist. And it's likely that if the organization has sort of like invested one bit in data engineering, they have a data engineering focused workflow orchestrator already available, and then a data scientist is sort of like, is expected to just sort of like move all of their workloads onto that data engineering ETL orchestrator, so to speak. And then there's sort of like an interesting question: how does that sort of like translation happen from all the work that the data scientist has done in their notebook into this workflow orchestrator? Now, one sort of like key difference between machine learning workflows and data engineering workflows is sort of like this notion of iteration. You're sort of like constantly iterating through a list of different hypotheses. You sort of like want to train on different kinds of features and whatnot. Maybe you want to run similar training workflows, but your hyperparameters are different, or maybe sort of your training seeds are different and whatnot. So there's constant experimentation that's happening, and there's sort of like a strong need to version everything. Understand sort of like what are all the experiments that you're running, what are the better performing experiments, how is sort of like are you actually sort of like making tangible progress towards optimizing the business metrics that you really care about. And then once you have, let's say, some kind of model, then comes sort of like the notion of deploying that model. Now, within an organization, you can use different machine learning projects, and each of those projects will have different requirements for deployments. I mean, of course, at Netflix, one end of the spectrum, we have Netflix recommendation systems, where the SLAs were really tied, the uptime guarantees that were needed from those model hosting services was sort of like really tightly scoped and required sort of like constant attention from an entire team of engineers from a DevOps point of view. On the other end of the spectrum, we also had many other applications that were in many ways driving as much business impact as Netflix recommendation systems, but the QPS that they were seeing was sort of like, barely sort of like, one request per minute and so on. So, but you can imagine, while Netflix is sort of like deeply invested in being on the bleeding edge of its recommendation systems, every single year it also spends $25 million curating a portfolio of content. And it's all sort of like machine learning algorithms that end up recommending to our internal content execs that okay, what kind of content they should be looking at, how they should be evaluating and whatnot. So all of those models, they are basically internal applications which see sort of like a handful of content execs logging in every few minutes or every few hours. You may have models that are deployed inside cell phones. You may have models that are sort of like just investigated in an offline mechanism. Some scores are generated, some instances are looked upon, and then those sort of like feed into, let's say, a Google log memo. That's an exec to sort of like look at to figure out what should they think about, let's say, pricing strategy for certain geographies. So deployments can come in a variety of different shapes and sizes, and it was important for us as a machine learning platform as well that we weren't taking sort of like too many strong opinions on how any given model should be deployed. Because not every single sort of like deployment strategy will fit all purposes. And then, if we look at sort of like, now slowly the stack is sort of like building up, and now we're sort of like, getting into this realm of modeling. Up until now, we've basically only spoken about engineering concerns. But now, as a data scientist, that person also has to concern themselves with that. What is the kind of data that they are staring at? Structured data versus unstructured data. What kind of machine learning algorithm should they use? What kind of features do they need to create and whatnot? And we see sort of like this stack merging at the end of the day, where from a data scientist point of view, what they would ideally want to focus on is basically the very top level of the stack. That's where their primary skill sets lie. That's where their sort of like motivations lie. That they give me a business problem and I want to sort of like translate that to such a problem into a mathematical model to figure out sort of like, what's the best way to sort of like optimize certain metrics. But then I'm yet to sort of like meet very many data scientists who really care about like, okay, how is the data actually stored in the data warehouse? Is it sort of stored in HDFS, S3, Snowflake, whatever? It's as long as they know what is the data that's stored, the data is of appropriate quality, and they're able to sort of like access that data as efficiently as possible without sort of like encumbering their iteration speed. It's a similar story with compute as well. Folks want access to compute resources, whether those compute resources are managed using Kubernetes or Mesos or something that is sort of like hand-rolled. Those are sort of like implementation concerns that usually sort of like engineers are a lot more opinionated about than data scientists themselves. And let's sort of like jump ahead. So we see sort of like this picture emerging in many ways, where we sort of like like the data science concerns are usually sort of like the very top levels of the stack, while all the infrastructure that we sort of like build in are sort of like located at the bottom levels. And it used to be sort of like this common joke that while our team was called the machine learning infrastructure team, we were basically doing infrastructure all day long and sort of ML. And now the question becomes that okay, if we have to sort of like, build this infrastructure, then what shape does this infrastructure take? Right? Like what is it that we're optimizing for? And the other sort of like big learning that we had during that time was if you look at sort of like the open source universe or the advancements that were happening outside of organizations like Netflix, both on the machine learning side as well as the infrastructure side of the house, those are immense, right? I mean, if you look back, let's say 15 years ago, 16 years ago, the average instance that you would find on AWS would have like 1.6 gigs of RAM. So it made sense to sort of like go out and like MapReduce style programming paradigms because very many problems could be solved on those sort of like very small instances. But now you can go out and you can get instances which have like terabytes of RAM, so very sort of like much more massive problems on a single instance. A lot of advancements being made on the machine learning side of the house as well. 10 years ago, 15 years ago, when Netflix started sort of like focusing on recommendations, they used to sort of like hand-roll all algorithmic implementations by themselves. But these days, it's sort of like a very simple install of TensorFlow or PyData that takes care of sort of like. There's also a lot of appetite from the business as well. Sort of like businesses, they progress, they mature up, they do make sort of like every sort of like 1% of gain in any specific business metric requires a lot of heavy duty work. Maybe you can't sort of like always rely on any closed form solution. So there's a huge demand for sort of like investing in machine learning. And the big gap that we see is that of productivity. Right? Like we are sort of like going out and hiring excellent data scientists, but then for them to actually deliver business value, not only do they have to be great at data science, but they also have to sort of like, really understand the internal engineering systems, business systems that exist. Because only when you sort of like master both, you are able to sort of like deliver the business value that the organization is. So we ended up building Metaflow in response to something that we were observing at that point in time. So the project started internally at Netflix in 2017. We spoke about the project here at PyData November 2019, and then December 2019, a month later, we open sourced it at 3-in-1. If you're interested in sort of like trying out Metaflow at any kind of time, we recently branched out and started a company as well called Outbounds, and we'll be able to sort of like find a hosted demo on a browser and give sort of like a quick demo towards the end of the talk as well. So that should sort of like reflect that there are data scientists at your workplaces who are interested in sort of like just looking at like, okay, what is it all about? Now it's a simple, straightforward way to get started. Now, what Metaflow essentially expects sort of like users to do is to sort of like basically take all the work that they have been doing within their notebooks and create a workflow of that, and to ensure that that process is sort of like super smooth and simple. All Metaflow expects is that you can basically copy paste different cells and create these different steps. So any Python function that you sort of like annotate with at step becomes the node in your graph, and then you see sort of like the self.next invocation that becomes sort of like the edge between different nodes. And you can create sort of like a variety of different graph structures as long as they're sort of like well-formed directly cyclic graphs to define your workflows. And now, I mentioned sort of like this notion of sort of like providing data access. Now, many organizations, they also invest in data query engines like Spark, Rester, and whatnot. And Netflix also had sort of like significant investments in that area. But what we observed was most data scientists, what they really want is fetch certain partitions of a given data table that, let's say, a data engineering team or some sort of like other ETL processes already sort of like landed in their data platform. And usually it's far more performant if you directly sort of like, go to your data layer and pull those, let's say, pocket shots back to your compute instance. And with Metaflow, we are able to sort of like provide throughput of the order of like 20-25 Gbps, which can be higher than the local disk that's attached to that compute instance. And what that means is that as the data scientist is iterating over different data sets, they can actually sort of like get access to those data sets in the order of seconds rather than waiting for minutes, which can sort of like lead to appreciable impact in any sort of activity. Now, back to Metaflow. Now, every single execution that happens with Metaflow that automatically gets version, it's assigned a unique run ID, and the entire internal state is snapshotted. So you can sort of like go back in time and say like, okay, here's my colleague. I want to know sort of like 6 months ago if they executed a workflow, what was the internal state of that workflow? What was the value of alpha? Sort of like an integer, a float in this case, it could be a model, it could be unchecked. Sort of like many more of these. And that sort of like provides people sort of an easy way to sort of like go back in time, observe not only their work but their colleagues' work as well. You can build up on top of that work and have sort of like interesting dependencies as well. That one team sort of like trains, let's say, a bunch of embeddings, and then the next team with their workflow, they can essentially depend on the other team's output, and let's say, always depend on sort of like whatever is the production version of that output. Now, all of this is sort of like great when you're sort of like confined to a single instance, but as I mentioned, right, like many times, the compute instance on which you're writing your workflow or your work, it may not be up to mark. You need extra resources, and with Metaflow, we try to sort of like make that very simple. So you see this add resources decorator. So in this decorator, basically what's happening is that automatically the train step will run on your remote compute cluster. This could be a Kubernetes cluster, on-prem in any of the 3 popular clouds. It could be an AWS batch compute environment, and the user doesn't really have to think about anything else. They still sort of like get interactive logs right back to their compute instance, and it will feel to them that as if somebody sort of like just walked in and added, let's say, 128 gigs of RAM to their workstation. And of course, you can sort of like do hyperparameter runs as well. At Netflix, we had an interesting scenario where there was like one single data scientist who was responsible for training models for Netflix's CDN infrastructure, figuring out what content should be cached in a given CDN box. And hyperparameter span for that was like close to like 60,000 or 100,000. So this one single data scientist for every single execution, they would sort of go out and run this massive workload all by themselves without sort of like really requiring any other engineering assistance in this. And then of course, the one thing that I had spoken about was it's all good and fine as long as you're sort of like executing and iterating from within your workstation, if you're sort of like spilling out to the cloud. But then there comes a time when you want sort of like things to run in some kind of like scheduled manner. Now the good thing is that it's very likely that your organization has perhaps already invested in an orchestrator. Maybe it's Airflow, maybe it's Argo workflows, maybe it's step functions, prefect, Baxter, whatnot. All of these workflow orchestrators, what they promise is highly available execution of a DAG. And with Metaflow, you've already sort of like executed a DAG, you've already authored a DAG. So we're able to compile down a Metaflow DAG into a DAG that all of these systems understand. And now all of a sudden, you basically get the best of both worlds. And now the good thing here is every single thing is also getting snapshotted here. So now if let's say any of these nodes fail, you can actually go back to your laptop and you can resume compute from wherever that workload failed, and sort of like fix it and then sort of like push it back to your Argo workflows deployment or your Airflow scheduler, and then the compute will sort of like back up from there. So it sort of like really simplifies your development moving into production and then after development process. And then of course, bunch of other features that we have introduced over the years. One sort of like big question that finds a lot of people is how do we do dependency management? If let's say we need to sort of like install TensorFlow, how do we even go about doing that? It can become sort of like really gnarly after a certain point in time. Some historical context. So at Netflix originally there used to be this one list Docker image that the data scientists would use, and it would come with like a less version of TensorFlow, or less version of PyTorch and whatnot. And then came sort of like an interesting problem when some data scientists wanted to use a different version of TensorFlow than what was provided. And now you can imagine sort of like, there are certain workflows that are already sort of like running in a stable situation using a certain version of TensorFlow. And you don't want to sort of like, move to a newer version of TensorFlow versus certain other people. They want to be on the bleeding edge version or the nicely released version as well. And with Metaflow, all of that becomes very simple and straightforward. Now, for different steps, different nodes of your graph, you can have different dependencies as well, and sort of like snapshot those dependencies and ensure that even if the upstream repository, for whatever reason, sort of like, goes away, your workflows will sort of like still continue to work without any issue. Of course, a bunch of other features which are more focused on sort of like collaboration and sharing, so you can sort of like group together workflows. You can imagine a scenario where you have users who have, let's say, a chain of workflows that sort of like trigger one after the other. But then now, if let's say a new data scientist comes in and they want to sort of like fork the entire chain and execute that, they would want to make sure that they don't end up overwriting any of your results, and things can sort of like run in a nice way right now. So those are all the guarantees that Metaflow sort of like will provide out of the box. So this was sort of like a quick pitch. Sort of like roughly 10 minutes, and I ran through this because sort of like just give a quick demo of everything that I've spoken about. If you're ever interested, the demo is hosted at howitlaunch.co if you want to follow along as well. Feel free to. But basically, if you go to howitlaunch.com, which is this website, you'll see sort of like the select for try Metaflow for free, and this will basically take you to this hosted VS Code experience. So here we see sort of like a very simple 3-step workflow. So we have the start step. The start step sort of like defines the self.next command, which sort of like moves the workflow to execute the eat step at the end of it. And if I execute this workflow, you can see sort of like I'm executing this workflow and assigning a run ID to this workflow. So every execution automatically gets assigned a unique run ID. And you can see sort of like all the print statements showing up here. And there's sort of like a nice little UI as well that allows you to sort of like monitor and track the progress of all the runs, and you can see how the logs show up here. One functionality that Metaflow comes with is this notion of Metaflow cards. So many times you want to sort of like document your work in such a way that every single time the execution happens, that documentation automatically takes place. This wall of text that you see that sort of like is guiding you through like what really happened is in fact a Metaflow card that automatically takes for every single run that you do here. So that was sort of like a simple example of a linear flow. We can have sort of like notion of branches where you want to run let's say workflows or like steps in parallel. That's sort of like super simple and straightforward. So rather than sort of like step.next just specifying one node, you can specify multiple nodes. So now if let's say I execute this, it can actually sleep for 10 seconds, it can just sleep for let's say 3 seconds. So you'll see sort of like at this point run ID 5 is assigned here, and this workflow starts executing, and the eat and the drink step they are now executing in parallel, and they all sort of select for 3 seconds, and then we sort of add a join step, and then the work is finished. And this card over here is actually just creating this DAG. You see sort of this execution time. Now, on the notion of sort of like artifacts and versioning. So anything that's assigned to an instance variable, like for example, x is assigned to 5 here, that gets logged by Metaflow. So of course, like if this was any arbitrary piece of Python code, you would expect sort of like the self.x equals 5, then the value of x, if I'm incrementing it by 1, then the value should sort of like show up to be 6, which is basically sort of like what we see here showing as well. So that's sort of like a earth-shattering here. Now if let's say I just change it to sort of like a different number, then we'll see sort of like Metaflow just like cataloging all of these different values within its metadata store, and the user doesn't really have to sort of like take any explicit action by themselves to record any of these values. All the logs are also stored in perpetuity, so I can sort of also go back and hey, I want like the logs for a specific workflow that executed, let's say a year back, and then sort of fetch that for you without sort of like the user actually having to figure out like, okay, how does it move these logs into some persistent storage. Now, on to sort of like the notion of, let's say, hyperparametric tuning. In the previous example, one of the previous examples, we saw sort of like how you could do branching. Here's an example of running, let's say, this step multiple times for different set of inputs. So what we're doing here is we're essentially instructing the workflow to execute the process step, but for each element of this list of data. So we'll run sort of like 2 copies of the process step that we see here. That sort of like makes it really easy for people to run very simple basic hyperparameter grid searches. Now, all of this sort of like at this point is running on this VS Code workstation. But as I pointed out before, right, like it could very well be the case that maybe you want to split it to the cloud. And Metaflow tries to make that very simple and straightforward. So in this example, let's say I have this Kubernetes decorator. So by default, it will run on, let's say, a pod which will have a single CPU and 4 gigs of RAM. So sort of like execute this. Basically, what's going to happen is that the start step is going to run locally on my laptop, and then the process step will run 3 copies of the process step in the cloud. And the user didn't have to sort of like worry about how to authenticate to the Kubernetes cluster, what are sort of like variety of different Kubernetes objects, how do I think about sort of like dockerizing my code and moving it to the cloud. All the logs will be fetched back to the user as well, so it will just seem that like somebody just came in and sort of like just added extra resources to their laptop. So let's see sort of like for example these processing statements sort of like show up here. So this, for example, is processing Apple. This command is actually this instruction executed within Kubernetes. So that's sort of like a simple, straightforward way for sort of like executing in the cloud. Now, in one of the steps, basically what we are trying to do is we are hogging a lot of memory, and it's likely that like maybe you don't really sort of like have a lot of resources available on your laptop because this step was actually running locally. So we can actually catch failures as well and not really sort of like fail the entire workflow if let's say one shot fails for whatever reason. But then if indeed you wanted sort of like more resources, then you could have as well. Just commented this out and execute this somewhere. So this is basically some of the rough features and like the basic functionality of Metaflow. Of course, if you want to demo, let's say the Argo workflows functionality. So only just by typing Argo workflows create, I can sort of like move my workflow onto Argo workflows. So for those of you who are familiar with Argo workflows, it has sort of like a notion of workflow templates. So it's sort of like show that here as sort of like a scale out flow. And now basically when I execute this flow, I can execute this actually right from here because this is sort of like a standard Argo workflow as well. And this will now start executing over here. And now for example, right before this talk, I executed this hello flow. And you can see sort of like this particular hello flow, it's a native Argo workflow. But then if you go to Metaflow UI as well, you sort of like see the sort of like show here as a Metaflow flow as well. And you basically at this point you're getting the benefits of both Metaflow and Argo workflows. And you can see sort of like this other workflow that we executed on Argo workflows working as well. And if let's say for whatever reason I go back to here and I decide to let's terminate this, right? And then basically what I can do is I can copy this thing here and I can go back here and I can ask Metaflow to resume that workflow from variable locally. So now you can sort of imagine, let's say your data distribution changes or something sort of like fails on your production workflow orchestrator. And if it's sort of really time sensitive, you want an opportunity to debug what really went wrong. And the first step to debugging any issue is to replicate that issue, like what really went wrong. And with this resume command, you can very easily sort of replicate that issue and like, for example, in this particular case, because I had the Kubernetes decorator, the process step is still going to sort of like run on Kubernetes. So yeah, that's basically the quick demo. And we're also almost out of time, so I'd be happy to take any questions. Yes.
Are we able to currently use Metaflow on GCP?
Yes, indeed. So we are just about to release an integration with GCP. So a month ago, we released an integration with Azure. So any day soon, you'll be able to use that.
Thank you.
Yeah. Yes, please.
So I saw you were like manually allocating memory with that process. Do you have to do that every time, or is there like a way to like automatically allocate memory that needed? Or
So you can set the defaults. So if you don't specify anything, the defaults would be taken care of. If not, you can always sort of like override and specify specific amount of memory or CPU, GPU. Yes.
I think I saw at the start that you had a Snowflake warehouse logo. I've seen a lot in my previous job that a lot of data scientists would reach for the warehouse and they would do a lot of stuff in the warehouse and then they would try and pull it into their Python process and do some stuff. How does that tend to work in practice with Metaflow? If you're maybe pulling 100 gigabytes of the network, but you're storing that in memory, does it fit on your laptop? Or in S3 maybe, if you've got like a workflow that's about to run. Yeah, how does that tend to work?
Yeah, it's excellent question. Now many times sort of like what we have seen users do is they'll sort of like push the query down to the data house, let's say Snowflake in that case, and then get the final result and sort of like move that either to S3 or to their compute environment. Or if they feel that they need to sort of like do some more sort of like queries that let's say Snowflake might not be able to support through just like plain SQL, maybe they want to use pandas and whatnot, then they also sort of like pull down the raw data down. Maybe sort of like the set of columns that we are interested in, dump that in S3 and then use Metaflow sort of like quickly that out of S3 and then use pandas on it.
That's excellent.
Yes, please.
Another GCP oriented question, but with the pending release of that, would the orchestration layer still be Argo on GKE or targeting Kubeflow?
So the orchestration layer for GCP would be Airflow and Argo workflows. And I believe Kubeflow uses Argo workflows behind the scenes as well. So we sort of like use it often anything if we start to use this.
It looked like what you were doing was you sort of had a Python file and then you would sort of run it and that would get submitted maybe to your Kubernetes. I'm curious how you do sort of like code versioning or change management along with that, such that you know only things that have sort of been approved and merged into your main branch or something end up getting run on the production system.
So yeah, of course, I mean, there are like two things, right? Like, so one is understanding what code was ever executed. So anytime you execute any Metaflow flow, we actually sort of like snapshot the code and the entire working directory, and we store that in S3 for you. And then now the other question about sort of like managing changes to sort of like the workflows. So many of our users, they sort of like layer in their own GitOps philosophy on top of Metaflow. So many organizations for sort of data privacy reasons, they may not want to give data scientists direct access to certain specific S3 buckets. And in those scenarios, people will sort of like work on some curated data set locally, and then submit their code up for review. And then once the review sort of like moves through, then the CI/CD process will basically execute the exact same command that I'm executing here, but then on behalf of the customer, and sort of like against some sensitive S3 bucket. So we're like relatively unopinionated about like how you want to actually stitch together your change management process.
You also mentioned sort of at Netflix having some Docker image that had the correct versions of all the libraries. I assume in order for this to run in an Argo workflow, you would similarly need some kind of base Docker image type for each of the.
Yeah, so basically if you want to submit yours, like if you want to specify your own image, all you need to do is just like who is your image, then you can specify an image type you want this. And then we'll use this image instead of the default image, which is an image for this.
Is there like a management interface, like provision compute power, memory, like how much users you use?
Yes, so there are sort of like additional pieces of functionality that we are building. So of course we have sort of like a plethora of CloudFormation templates and Terraform templates that allow you to configure however amount of compute is available to your entire organization. We've been working on sort of like introducing some more fine grained controls for folks. But then there are definitely fail safes baked into Metaflow. Of course, you would want sort of like somebody to run, let's say, 100,000 way for each and take over the entire cluster. So when we sort of detect that there's sort of like a large amount of compute involved, you actually sort of like give the user an indication that this is really something that you want to progress. Any other questions? Yes.
There's a data store concept, right? Where data artifacts,
Yes.
code, snapshots of stored.
Yes.
So there's a way. What's that expiration?
Totally depends on how you want to set the expiration. So basically, you sort of like you can bring in your own S3 bucket, Azure block container, or your GCS bucket, and then you're free to sort of like set your own license. This is for some of you. All right. Thanks for joining.